Okay, ladies, let's wrap up the kidney. Okay, so we left off talking about the kidney. How was your weekend? Good? Had a good weekend? Excellent. I was at camp all this weekend. It was good. Kids were good. Yeah, loud, enthusiastic, crazy, energetic. Hopefully they're tired today. Okay, so we left off talking about how the kidneys work, right? So who wants to review it? How does it work? So how do things get into the kidney? So if we're looking at this part right here, how do things get into the kidneys? How does that happen? What's that process? You learned about it in grade 9 using paper. Yeah, it's filtration, right? So stuff that can filter through the capillaries. What can filter through? Anika, give me an example of a substance that can get through and into the nephron tubule. So what can get into this tubule? Water. What would be something else? Salt. What about sugar? Yes or no? Can sugar get through? You sure about that? If someone has diabetes, what's a test you could do? Test for what? In their urine. What can you test for in the urine? Sugar. So if sugar can end up in the urine, that means it can get through, right? Now, we'll talk about normally why it shouldn't be in the urine. We'll talk about that in a second, okay? Alright, maybe not a second, but in a few minutes. Now, how does it work? So, whenever we talked about, the idea is that outside the tubule, there is a concentration gradient of solutes. And as you go down this way, the concentration of solutes increases. So that on this side, the water gets pulled out because the outside is hypertonic. Now I need to throw out the word hypertonic. You know what the word hypertonic means? It means that has more what? Solutes. Okay? As the water comes out, what happens to the filtrate though? The filtrate becomes what? More or less concentrated. As something loses water, does it become more concentrated or less concentrated? More concentrated. Right. Because you have the same amount of solutes, but less volume. So if V goes down, that means C goes up. You can see it in this formula right over here. Okay? So if V goes down because we lose water, that means C, concentration, goes up. That's why these numbers go from 300 to 400 to 600 to 1200. Because it's losing water. Then what happens as we go up? What happens? Opposite. Solute comes out. Because diffusion says things want to move from high concentration to a low concentration. But you can see over here that it's not just diffusion, because I don't have my mouse, sorry guys. I don't know what happened to it. I'm using my hand here. Diffusion would balance things out. But you can see that the concentration is actually less inside than outside. So it can't be just diffusion, it's also active transport. Okay? Pumps are going to be involved. And we'll talk about that a little bit later. We showed you an animation that went over this. Okay? So it was over here. But we left off talking about what happens if you're well hydrated. What does that mean if you're well hydrated? It means you've had enough what? Water. What's the opposite of that? Let's talk about if you're dehydrated. Now, if you remember, nothing happened after this point. So you can see here's we're going up the ascending limb, the solutes coming out. Okay, not all the solutes. Specifically here, it's the salt, the sodium. You can see the sodium ions going out. We know we talked about it's passive and active. And then what happens if you're hydrated? That's the end of the story. Nothing else happens. But if you're dehydrated, there's a hormone that comes in. It's highlighted here in yellow. It's called the Antidiuretic Hormone Adh. Okay? And what it does is the following. Okay. So when antidiuretic hormone is not released, this is what happens. Nothing. Okay? You see, the solute concentration did not change. Nothing got pulled out. Okay? This, by the way, this is called the collecting duct. So nothing got pulled out. But if you're dehydrated, this is what happens. The antidiuretic hormone opens up the collecting duct. So now the collecting duct looks exactly the same as what? As the descending limb, doesn't it? It looks exactly the same. So the difference between well-hydrated and dehydrated is in well-hydrated, you're basically using these two parts. Okay? Whereas when you're dehydrated, you're also using the collecting duct, using the descending, ascending, and the collecting duct. Okay? Why? Well, if you're dehydrated, what do you want to conserve even more? Yeah, you want to conserve more water, right? So what you're trying to do here is you're trying to not only reabsorb water here, but you're trying to reabsorb water again over here. Okay? So you're trying to reabsorb more water. Okay. All right. So we talked about the way it works. We talked about ADH. Okay, that's what we just thought is ADH. So this is a slide about ADH. Basically, we talked about how it increases the permeability. Remember, impermeable means nothing can get through. Permeable means it can't. So ADH works on the collecting duct. So how does it get triggered though? Like, how do you know you're dehydrated? So something in your body has to, just like we talked about thermoregulation, there's got to be a detection system, right? Well, again, it's in your brain. So how does it work? This shows you. The idea is this. When you don't have enough water, that means there's going to be less water in your blood because you're dehydrated. Okay? Not enough water in the body. That means not enough water in the bloodstream. Well, according to our formula, C equals N over V, if there's not enough V, what happens to C? C goes up, right? So the blood becomes concentrated, right? Now, here's the thing. What does your blood provide cells? You learned this in grade 9 or 10, right? Cells are surrounded by blood vessels because the blood vessels provide what? Oxygen and nutrients, right? But the cells are full of water. Outside the cell is full of water. The bloodstream has water in it. But which way does the water move? It always, well, not always, but it moves towards the what? Side that's more concentrated. Here's the problem. If you're dehydrated, the blood is concentrated because you don't have enough water. So what happens is this. The cells that are being fed by the blood vessels will lose water to the blood vessels because the blood vessels are hypertonic to the cells. So there's special cells in your hypothalamus, which is a region in the brain. And if you're like, where did I hear that before? That was the same region that detected the temperature. Those cells will shrink because they lose water to the bloodstream because the blood is concentrated. The shrinking is the sign that you're dehydrated. Okay? When they shrink, there is a message that gets fired from your brain. You can see it right over here. So the ADH actually comes from your brain. That message travels through your bloodstream, targets the kidneys, and it specifically targets the collecting ducts of the kidneys. Okay? So this is the collecting duct. Remember, this is the descending limb. This is the ascending limb. This is the collecting duct. Okay? So the trigger mechanism is you're dehydrated. The blood has less water in it, so the blood's concentrated. The cells then lose water to the bloodstream. The cells shrink. That triggers the release of ADH. The ADH then travels to the bloodstream, targets the kidneys, and opens them up. Okay? So it opens them up. So the ADH, not only does the ADH open up the collecting duct, it actually works on a protein called aquaporin. Now think about the name of that. Aquaporin. What's aqua? Water. Porin. If I think of the word pore, I think of what? No, pore. Like a pore in your skin is an opening. Okay? So aquaporin is an opening that allows water to travel through it. Okay? It's a protein. So ADH, not only does it actually promote the transcription, which we studied, transcription, studied that before. Not only does it promote the transcription of aquaporin, but it also opens it up. So this is what it looks like. So up here, this is aquaporin when it's closed, and then it swings open in the presence of ADH. It'll look like this. Here's a picture that actually shows you the aquaporin protein. Okay. So here's your aquaporin protein, and you can see water. These little V-shaped things, that's water traveling. And I really don't know what side's the inside and what's the outside, but you can see the water crossing from one side to the other. Okay, so that's the aquaporin opening up. So that's if you're dehydrated. Okay, so let's talk about things that can affect the reabsorption of water, okay, or salt. Because now we have an idea of how the kidneys work, right? It works based on two principles, osmosis and what? And diffusion. We talked about how the kidneys work, so now see if we can understand maybe some complications. All right. If you have type 1 or type 2 diabetes, right, one of the signs is going to be sugar in your urine. Now, one of the symptoms, because it's not like you're going to notice the sugars in your urine, okay? The only way you'll know that is if you go for a test. Like your doctor does a urine test and he tests for sugar. Now, one of the symptoms that you might notice is that you might urinate more frequently. Why? Why would there be a connection between having sugar in your urine and urinating more frequently? Now, so if you understand how the kidneys work, then you should be able to figure that out. So think of it logically. Just one simple rule. Water follows what? Water follows the what? Starts with an S. Or water goes to the side that's more what? More concentrated in terms of what? Starts with an S. Not solvent. Water is a solvent. Solute. Okay? So in other words, water goes to the hypertonic side, right? And that's how the kidneys work in terms of water movement. Well, here's the thing. What's sugar? What is it? Sugar and water is a what? It's a solute. So what happens if you have too much sugar in your urine? That must mean that there was too much sugar in the... Because remember, the stuff that goes in the urine would have come initially from the nephron tubule, right? Because everything in here that does not get reabsorbed, where does it go? In the urine. So that means the sugar would have come from the nephron tubule. Well, if there's too much sugar in the nephron tubule, the sugar is a solute. Now we have more solutes in the nephron tubule than we normally would have. How would that affect the movement of water then? What's that? It's harder for the water to come out. Because there's more solutes in the tubule, more water stays in. Just to give a simple rule, the water follows the solute, right? So if more solute comes out of the tubule, more water comes out. If more solute stays in the tubule, more water stays in the tubule. Okay? So one of the signs for if you have type 1 or type 2 diabetes, but do you know the difference between type 1 and type 2? Type 1 is like an autoimmune disorder. You normally see it as a young person. Your immune system attacks the cells that make insulin, which are called the beta cells. Type 2 diabetes is more like something that you acquire over a lifetime, where you probably have a diet really rich in sugar. And you normally see type 2 diabetes like later on, like 40, 50, 60 years of age. So in either case, though, that's the sign is increased urination. Okay. There's a different type of diabetes. It's called diabetes insipidus. Okay. And diabetes insipidus is not the same as diabetes mellitus. Okay. Diabetes mellitus, that's a type 1, type 2. That has to do with insulin or insulin resistance. Okay. Insulin resistance means that your body does not respond to insulin. Diabetes insipidus is when you don't make ADH or you don't respond to it. They both have the same symptom in terms of increased urination. Why would someone who doesn't make ADH have increased urination? One of the things you'll be seeing in this unit are case studies. So I'll give you like a patient, give you some symptoms, you got to figure out what's wrong with them. Okay? So you got a patient who has maybe some physical trauma to the head, right? Maybe damaged part of the brain that produces ADH. Okay? Why would a symptom be increased urination? If that region is damaged, maybe you're not making ADH. Why would that be a symptom? Increased urination. Because you just saw, what does ADH do? ADH makes you reabsorb more water. So if you reabsorb less water, that means more water is going in your what? Urine. Which means you got to go pee more, right? By the way, it's the same effect. Whether you don't make something or you don't respond to it, in biology is pretty much the same thing. If we don't make insulin or you don't respond to insulin, they're equivalent. So in other words, do you guys know what insulin does? Insulin tells your body to what? Store sugar. If you don't make insulin, or whether you don't respond to it, it's the same effect. You don't store the sugar. ADH says reabsorb more water. So if you don't make ADH or you don't respond to it, it's the same effect. You don't reabsorb more water. I want to mention something quickly about the sugar, because I said to you that the sugar in the urine shouldn't really be there. Why is that the case? Sugar can get through, right? Sugar can get through because it's small enough, so it can get through. If normally it doesn't end up in the urine, what does that tell you then? That tells you somewhere along the line it must have been what? Reabsorbed. So up here in the proximal tubule, there are transporters that bring in the sugar. Okay? They basically move the sugar back into bloodstream so you don't get rid of it. Which makes sense because in biology, do you really want to get rid of sugar? What does sugar represent? Think back to chapter 2. What does sugar represent? Right, it's fuel for respiration. So you don't want to get rid of it. But the problem is if you have type 1 or type 2 diabetes and you're not using proper medication, too much sugar ends up going into the nephron. Okay? Because your sugar levels are really high and the insulin is either not being released or you don't respond to it. So the problem is the sugar levels don't drop enough. Too much sugar goes into the nephron and there's just not enough time to reabsorb all of the sugar. So you can reabsorb the sugar, but if there's too much of it, a lot of it gets through and stays in the tubule. Okay? A normal person would have less sugar would go through and it would be all absorbed. But if you have too much sugar going through, then a lot of it will stay in. Okay. Questions about ADH and diabetes and nothing? You sure? Okay. I want to talk about blood pressure. What's good? High blood pressure or low blood pressure? It depends. Well, you don't really want low blood pressure. You don't want high blood pressure unless you're exercising. You want high blood pressure when you're exercising. But you don't want, you want to, this whole unit is about what? Maintaining balance, homeostasis. So let's talk about blood pressure. We know that when you're at rest, it shouldn't be high and it shouldn't be low, okay? If it's high, it's a sign that there's something wrong, okay? Could be many things. If it's low, it's also a sign there's something wrong. And the problem with low blood pressure is the blood does not circulate very well, okay? So they're both bad. You want something in between. So let's talk about what happens if your blood pressure is elevated, okay? Or when it's low. So let's start with blood pressure is low. So we'll talk about blood pressure has decreased, okay? We're going to look at what happens. So I'm going to be really, really simple with this, okay? There's a bunch of hormones that get released. The one I'm going to focus on is something called aldosterone. Okay? So here it is over here. Aldosterone is right here. Okay? Now, what aldosterone does, and you're going to see if you can figure out why this would increase blood pressure. So remember, this is in response to low blood pressure. Okay? Low blood pressure. So one of the things that happens is a hormone called aldosterone gets released, and it comes from the adrenal glands, okay, which sits on top of the kidneys. What aldosterone does is it increases the reabsorption of salt. So you get more of this. More salt gets reabsorbed. Why would that increase blood pressure? Why would that increase blood pressure? And by the way, the way the hormone works. So there's do you guys ever study the sodium potassium pump in grade 10 or 11? Did you? Okay. The way it works is so I'll draw it like a circle. So what it does is it basically moves 3 sodium ions. Wow. Sorry, guys. 3 sodium ions one way, and it moves 2 potassium ions the other way. Okay? So you're moving 3 sodium ions one way and 2 potassium ions the other way. The way they're oriented here in the ascending limb is 3 sodium would go this way, so the sodium would be reabsorbed, whereas the potassium would be excreted, released into the urine. Okay? And if you think about that, every time the pump works, what do you gain? You reabsorb 3 positive ions, but you get rid of 2. So what do you gain? You gain 1. So every time the pump works, you're gaining positive ions, which is a solute. It's part of positive ions are solutes. Why would that increase blood pressure? So think of that simple rule I gave you. Water follows the what? What does water follow? The solute. So when aldosterone's working, you reabsorb more salt. That means you reabsorb more water. If you reabsorb more water, where does that water end up going? Back into what moves the water around your body? What moves the water around your body? Think about the way the nephron is organized. What surrounds the nephrons? Blood vessels. So, aldosterone increases salt reabsorption, which increases water reabsorption. More water goes into the bloodstream. What happens when you put more fluid into a vessel? What happens to the pressure? It increases. Okay? So aldosterone increases blood pressure because you reabsorb more salt, which means you reabsorb more water, and reabsorbing more water will increase the blood pressure. What if your blood pressure is too high, though? So what could you do if it's too high? Do the opposite. So there's a hormone, and we're going to be studying this in this unit, antagonistic hormones. You guys study English, right? Do you know what the antagonist is in the story? It's the opposite of the protagonist, right? Protagonist is the hero, antagonist is the villain. Now, AMP is the antagonistic hormone. It's not a villain, but it does the opposite, okay? What AMP does is it reverses that. It tries to promote the excretion of salt. So if you get rid of more salt, that means you get rid of more what? Water. That means less water in your bloodstream. That means the blood pressure would go down. It's the exact opposite. Okay? Exact opposite. So what I want you guys to get out of this is how the kidneys work. So we talked about the role of osmosis and diffusion. I want you to understand, if there's an issue with the kidney, what would be a symptom and how would you explain it? So, for example, why does someone have increased urination with diabetes? Okay? And I also want you to understand how some of these hormones work. All right, ladies? And that, my friends, is it for osmoregulation.